Welcome to my YouTube channel Manoj Networking. So today we'll see what is an ARP, what is a ping and what is a trace route. So these are very important to understand for the networking team. So let's see one by one what is an ARP, ping and followed by trace route. So ARP stands for Address Resolution Protocol. So ARP stands for Address Resolution Protocol. So this is a layer 2 protocol. Layer 2 protocol used to help your used to bind your MAC addresses to IP addresses. So just repeating the statement one more time. So Address Resolution Protocol is a layer 2 protocol used to map your MAC addresses to IP addresses. So let me explain with some OSI reference model so that you can get the idea clearly. So I hope you guys know about OSI model, right? Like let's say we have first layer, layer 1. So this is a physical layer, and here we have layer 2 and here we have layer 3. So physical layer, so this is a data link layer and this is a network layer and this is a network layer. And what normally we'll do here, so here in the layer 2 we have the switches. So here we have the switches will be working with the help of MAC addresses, and this MAC is a 48-bit address, whereas in the layer 3 network layer all the routers will work, and it will work with the help of IP addresses. So IP address is a 32-bit. If you see, I mean, like, you know, the technologies are completely different. So here it is a MAC, here it is an IP address. Or if I tell in a layman example, so like let's say in layer 2 all the users are talking Japan language, talking Japan language. In layer 3 everybody is talking Swedish language, or you can consider Hindi also. Okay, but if you see, if any communication is going from layer 2 to layer 3, both languages are different. MAC address doesn't know what is an IP address doesn't know what is an MAC. Okay, so to mitigate these kind of problems, there came one language called English. So here this English language is universal. In the same way, here in our networking industry, so there came one protocol called ARP, Address Resolution Protocol. So what it will do, it will mix match layer 2 and layer 3. So ARP is an address resolution protocol, so it will help you bind your MAC addresses to IP addresses and vice versa, IP addresses to MAC addresses. So a address resolution protocol is a layer 2 protocol used to map addresses to the IP addresses. So all hosts on the network are located by their IP addresses, but NICs doesn't have any IP addresses. They will have MAC address only. So ARP is a protocol used to associate IP address to the MAC address. So an IP address will be looking like this. So 192.168.1.1 will be looking like an IP address. So this is in layer 3. So like let's say a MAC address will be looking like this, 00BF C2DE. So this will be identified by layer 2 switches. So to mix both of these people, ARP will come by default, and we don't need to run any special commands to get your ARP running. So by default, our vendors who are manufacturer of our devices, so they have already manufactured like that. So if I open command prompt, even we can even see from our personal computer or from any office computers also. If you type ARP-A, now if you see at this given point of time, my computer is making these many connections, and you can see clearly here. So internet address is 208.66 and it is associated with this particular MAC address, and the dynamic entries you are seeing here. Okay, so the command is so simple, ARP-A. Okay, so to demonstrate further, let me use the packet tracer lab. So here what I am using, I am just using one single switch with 2 computers. So let me quickly assign the IPs here. So 192.168.1.1 and here 192.168.1.2. So let me quickly assign the IPs. So go to desktop IP configuration, So 192.168.1.1 with 255.255, and yeah, if I close this, if I go to command prompt, so I am in the command prompt of PC0 now. I am in the command prompt of PC0. You can see here. So if I ask ARP-A, now if you see, no ARP entry is found because this is a brand new computer, this is a brand new setup, and no communication is being made from 1.1 to 1.2 or from 1.2 to 1.1. No communication is being happened. So let me quickly assign the IP address here also. So here it will be 192.168.1.2 with 255.255/24, 255.0, and we don't need any default gateway for this lab, and that will be absolutely fine. Okay, now if I go to this computer and if I just try to simulate some traffic from PC1 to PC2, so 1.1, let me do IP config so that you can see the IP address. So I am in 1.1 computer, so let me try to simulate the traffic to 1.2, 192.168.1.2. Yes, very good, I can reach it. I am able to reach the other the device. But if I ask now ARP-A, you see now this is a dynamic entry, so automatically the particular IP 1.2 is being registered with this particular IP. That means this computer now sitting 1.1 is able to talk to 1.2 with the help of this particular MAC address. So this is the MAC address that we are talking. So this is a 48-bit MAC address, and this is how it will be. And MAC addresses are unique. So no two devices can share single MAC. That's not possible. So no two devices can share single MAC. That's not possible. And these are all dynamic entries. And this is completely dynamic table. Like let's say after some time you have added one more computer. So let me quickly add one more computer. So if I just quickly connect from fast Ethernet 0/3 to this computer, so let's make it fast forward. So we'll assign here 192.168.1.3. The IP address of this computer is going to be 192.168.1.3 with 255.255.0. So now if I make 192, let me try to ping 1.3. Okay, now if you see, the communication is happening, and you see guys, now the ARP address is being added. So in this way, in real time also, the ARP addresses will keep on adding by your computers. So you can see this is a layer 3 address. It is particularly mapped to layer 2, and automatically these changes will be happening. So this process is called as an ARP. Address Resolution Protocol. So let me come up with one more example. So here an IP address is a 32-bit, however MAC addresses are 48. So ARP translate that 32-bit to 48 and vice versa. So let me demonstrate with one more example. So here is my PC. So here I am sitting in my company. So I have an IP of 10.1.1.1 and my MAC is AAA. Okay, so now if you see, once the packet or frame will go to this particular switch, so it will prepare these many things. Now if you see, what is the source IP? Source IP I know. What is the ICMP? So ICMP stands for Internet Communication Messaging Protocol. So ping and trace route will come in that part. I'll just talk about in a while about ICMP, ping and trace route. But if I try to ping 10.1.1.3, so ICMP will be coming. Source IP I know. What is the source IP? What is the source MAC? What is the destination IP also I know. Destination IP is 10.1.1.3. But if you see destination MAC, I don't know. So that's why the packet or frame will reach to the switch, and what switch will do? Switch by default it will send the information to all the connected neighbors. So now switch 1 will send that information to switch 2, and it will send that information to switch 3. All the way it will reach to complete your LAN, and finally they will validate who are all connected. And now if you see, this is the correct person who is having that particular IP, and now the switch is looking for this particular MAC CCC. Now if you see, the switch 3 will reply back to switch 1, and now switch 1 will add CCC. So now this switch also will make entry. Like let's say if I wanted to go to top 10.1.1.3, so his MAC address is CCC. So even we can see, if I ask show IP ARP, this is the command. So if you ask in the switch show IPR, it will also maintain one state table. It will also maintain one state table. So this complete process is called as an ARP. This complete process is called as an ARP, address resolution protocol. I hope the ARP is clear. So moving further, let's see what is an ping and trace route. What is an ping and trace route? Again, these are very basic commands, but we should understand what is the use of ping and what is the use of trace route. So basically, ping is a basic internet command that allows an user to test and verify whether a given destination IP address is exit and can accept the request in your computer administration. So like let's say if I go back to my lab, the simple lab, so you can see since I am seeing my screen, so I can say now 1.1 is talking to 1.2 and it is talking to 1.3. So like let's say you have one office in India. You have one office maybe this switch is in India. Maybe this switch is in India. This is sitting somewhere, maybe some other building. Like let's say this is sitting in building 2. This is sitting in building 1. Okay, now this is your computer. This is your computer. You need to know either we are able to reach this particular address or not. 192.168.1.3 I am able to reach or not. So what you can do? So you can ping from here. You can do a ping from here. Ping means it will help you identify is this the destination, is this destination 1.3 is active or not, is this destination 1.3 is active or not. So if it is an active, you will get response like this. So like let me go to command prompt. So ping 192.168.1.3. you see guys now. So if the remote destination server or anything, whatever the thing I am trying to ping for the destination, if that is active and working, so I will be sending 4 bytes, receiving 4, and last is complete 0%, and last is completely 0%. Like let's say if I shut down, so how to shut down? So let's go to FA0/3 and let's shut down that destination. So enable config t interface FA0/3 and shut down. Okay, wantedly I have made your server or this particular computer, I have made it shut down. So now if I try to ping, if you see, you will get request timeout. Why means, so here this will prove me sitting from source computer, I can ping to destination server. So I can see either am I getting loss or the pings are successful. Now if you see in this case, the destination is not reachable. You are getting request timeout. So now if you can see here, sent 4, received 0, and all 100% 0 loss. Okay, so now you need to identify this particular server or this particular computer is not responding for you. Then as a network admin, you need to see why, what, when it went down. So those kind of things you need to troubleshoot. Again, it's always recommended to do the troubleshooting from layer 1. So OSI model is very important. Just look for layer 1 problems and then identify layer 2 and then look for layer 3. So that's how you need to troubleshoot the issues in real time. And moving further, it has one more peer. So basically ping and trace route, they both will come. So as I said, ping is a part of ICMP protocol. So ICMP stands for Internet Communication Messaging Protocol. So ICMP is equal to ping and trace route. So both these protocols are part of your ICMP. So ping can also be used with any operating system. So it doesn't matter you have Linux, you have Mac OS, you have Windows. So this ping and trace route will work for any operating system. So that supports networking, including the majority of embedded network administration with software. So trace route. So trace route stands for how the connection is traveling from source to destination. So trace route also plays an critical role in our networking field. So trace route will help you identify how the connections are being traveling from source to from given source to destination. Like let's say I have 2 routers. So for example, on this same topology, let's draw 2 routers. So this is my router 1, this is my router 2. Okay, so like let's say this is also having internet connectivity. So destination is 8.8.8. So destination here also 8.8.8. So So here maybe it has an IP of 1.1.1, so here it has, this router has an IP of 2.2.2. so if I go and this computer, if I ask trace route your 8.8.8.8, so it will say first I am going to this switch, so now it will say I am going to switch, and then it will say maybe I am going to router R1, I am going to router R1, I am going to router R1. So through this output only we can see which path is the preferred, like let's say if this 1.1 is going down, and automatically the traffic also can be diverted to 2.2. so this kind of scenarios I will be talking while discussing about the routing. So please do follow my channel. So if the command for trace route is, so in this case you won't have any hops, so you will not get many things, but this is the command. So this is how we can do a trace route. If you see, tracing the route to this destination over a maximum of 30 hops, so now 1.3 it will not reach, because 1.3 is currently down. So let me try to ping 1.2 so that you will get it. Yes, this is also very important. So like let's say your destination is down, so you will get this kind of message. That means you need to understand, starting from first hop itself, the particular destination is down, and you need to troubleshoot accordingly. So now if you see, if your destination is up and working, so your trace route will also get complete. And sometimes if any end users are reporting issues, like let's say they are having latency, so that time you will see some milliseconds here. So if you have any latency, that also you need to troubleshoot.